Hey kiddos! Today we are going to be talking about equations of circles. So let us begin. Looking at circles, if they are on a coordinate plane, let's talk about writing and graphing equations of circles first. So as you can see here, we have our circle on a coordinate plane, and we're going to let x, y, so this point right here, represent basically any point on a circle with the center at the origin. We know origin is 0, 0, with a radius of r. So we can actually use Pythagorean theorem to help us solve the equation of a circle by realizing that instead of using a squared plus b squared equals c squared, we instead would be using x squared plus y squared equals your radius squared. Okay, this is the equation of a circle with the center at the origin. Okay, very important. This is what you would use for your equation when the center is at the origin, which is 0, 0. So now let's look at standard equation of a circle, which gives us a little bit of a different formula. All right, so in this case, we're going to let xy right here, represent any point on a circle with the center at HK. So notice the center is not our origin, okay? It can be any point, okay? And a radius of r. By Pythagorean theorem, you would take x minus h squared plus y minus k squared, and it would equal your radius squared. This equation right here, okay, is standard equation of a circle with a center at HK, which means HK is not necessarily the origin, as you can tell here, okay? So this would be the formula that we would be using for a standard equation of a circle with a center not at the origin. All right, so let's look at our first example, writing the standard equation of a circle. Write the standard equation of the circle. So here is our circle, and we first need to figure out what is the radius, what is the center, and then we can write the equation. So I do notice that the center for this one is actually at the origin, and I can tell that because I can go 1, 2, 3 to the left, and I reach the circumference, and I can also go 1, 2, 3. Oh, that's left. I don't know my left and right, obviously. So I can go 1, 2, 3 to the right and get to the circumference. And then from the center, I can go 1, 2, 3 to the left and get to the circumference. So, and I can also notice that going down, I can go down 3 to get to the circumference, to the perimeter. I guess you would call this as another way. Or 1, 2, 3 up. So the radius then has to be 3 units, which would mean that the center justifiably is going to be the origin. So remember, if it is the origin, we kind of have a shortcut here, or you can imagine that your h and your k would be equivalent to 0, 0. So they don't exist in the actual equation in standard form since h and k are 0. So simply our answer would be x squared plus y squared equals 9, because that's what 3 squared is. Okay, so that's how we got 9. All right, moving on. So now let's look at writing the standard equation of a circle with the center at 0, -9, and has a radius of 4.2. So first, they've given us our center point of our circle, so I'm going to mark that as HK. And that's our point for the center. So when we're plugging into our formula, which you can see is right here, you will notice we would get x minus h, which is 0, squared, plus y minus -9 squared equals r, which is radius, 4.2 squared. All right, so when we simplify that, x minus 0, well, really we don't have to put the minus 0 part, so that part just becomes x squared plus y double negative means it turns it into positives. So we would have y plus 9 squared equal to 4.2 squared is 17.64. So that would be the equation of a circle with the center of 0, negative 9 and a radius of 4.2. All right. So for this example, we are going to write the standard equation of the circle, but we need to determine what is the radius, what's the center, and then we can write the equation. So looking at this circle, we need to figure out where the middle of it is. And to be honest, it looks like it is that point here, but let's check. I'd go 1, 2, 3, 4 to the right, and 1, 2, 3, 4 to the left. So far, so good. And then down 1, 2, 3, 4, and then up 1, 2, 3, 4. So I believe I have the center marked, and I've also mentioned what the radius is. So the radius is 4 units. The center is at negative 5, 4. I'm also going to put the letters H and K at the center because I'm going to need that for the equation. So now when I plug this into the equation, we get x minus h, which is negative 5 squared, negative 5 squared, plus y minus k, which is 4 squared, equals radius 4 squared. Now let us simplify that. I notice here that becomes double negatives make them positive, so you end up with x plus 5 squared plus, I can't simplify anything there, so that would stay the same, equals 4 squared is 16. So the equation of the circle is x plus 5 squared plus y minus 4 squared equals 16. Just a few things to note that if you're ever given the equation, okay, you can get the center by looking at these two values and making them the opposite. So the x value of the center would be the opposite of positive 5, which is negative 5. The y value of your center will be the opposite of negative 4, which is positive 4, as you can see there. And then to get your radius, you would take this value and just take the square root of it, as you can see, and you'd get 4. That's kind of how you can work backwards if needed. All right, looking at our next example, we're going to continue to write the standard equation of a circle, but this time we are told that we have the point, negative 5, 6, here is on a circle, with the center being at negative 1, 3. They want us to write the standard equation. Well, in order to do that, we have to know what the radius is. So, as you can tell here, I have drawn a right triangle. So I've drawn a line across from here to the center and then down to connecting the center. And I have marked what those values are. This was 4, this is 3. And I can use Pythagorean theorem to figure out what this hypotenuse is, because this diagonal is my radius. And hopefully you all know this is actually a Pythagorean triple. So the answer would be 3, 4. Radius would have to be 5 units. Okay, so now that we have that, we can write our equation of the circle with the center being at negative 1, 3. So therefore that is my h, that is my k. And we would have x minus h squared plus y minus k squared equal to r squared, which we discovered is 5 squared. And let's simplify this. So we see that we have a double negative there, so that becomes positive. So you get x plus 1 squared plus, can't simplify, y minus 3, so that stays, y minus 3 squared equal to 5 squared is 25. So the equation of this circle is x plus 1 squared plus y minus 3 squared equals 225. All right, now for this last example, you are actually going to need a compass, and it's a tool that we use in geometry to help draw circles. Yeah, so let me go ahead and at least explain the problem. The epicenter of an earthquake is the point on the Earth's surface directly above the earthquake's origin. Okay, a seismograph can be used to determine the distance to the epicenter of an earthquake. Seismographs are needed in 3 different places to locate an earthquake's epicenter. So, what we would do here, if I have a compass, notice I've already plotted point A, point B, and point C because you have to have 3 different locations. And they've also given us basically what the radius would be for all 3 of those locations. So if you were to take your uh, compass and mark it 7 units from A and draw your circle, it would look like so. And then from B, you would mark it with 4. So it would look like so. And remember, this is the center. And then C, you would mark it with 5. So it would look like so. You can see that all 3 circles would intersect at this very same common point. And this common point right here, so just to kind of draw what it would look like, that would be circle A. Circle B would look something like this. Sorry, I know it's crooked. And then circle C would look something like this. So where all 3 circles converge is at this point, and this point would be the epicenter, which is 5, 2. Notice, like I said, you would have to use a compass to be able to draw these circles a lot more accurate. So, yay, we're all done.